Okay, what we just did on the dartboard down in the basement was I threw the dart 20 times, and I got it 6 out of 20 times, and we said that's 3 out of 10, which is equal to 30%. Okay? This is one of the three basic common methods that are used to calculate a probability. This method actually has a name. Our textbook calls it the relative frequency approximation method. And it's just an approximation, obviously. Anytime we do an experiment, we know that from one time to the next, our results can change. But this particular time, I was able to come up with a 30% success rate. Now, in general, the relative frequency approximation method uses the following. Given an event that we would like to key in on how often it'll occur, given an event, let's call it event A. In my case, it would be hitting a 20. Given an event A, the probability that A occurs in an experiment is equal to the fraction where on top is the number of times that the event did occur. For me, from getting a 20, that was 6 times. And the denominator is going to be just the number of times that the trial was executed. And of course, in our example here of the dartboard, the execution of a trial is simply just the throwing of the dart. This is the formula for finding a probability based on an experiment, and this is called the relative frequency approximation method. Now, other method is not based on an experiment. Another method of calculating a probability is when we have no doubt. We can calculate exactly what the probability is, such as the probability of getting a particular value and rolling a dice, or given a deck of cards, probability of coming up with a particular suit or a particular card. In this case, if we have an event, once again, given some event that we're interested in its occurrence, if we have an event A, then the probability that event will happen is also a fraction, but it's important to note at this point that we have a particular set of outcomes for a well-defined random procedure, and in order for this formula to work, every outcome has to have the same chances occurring, such as rolling the dice. Everyone has a 1 out of 6 chances of occurring. If that's true, then the following formula will work. It is, the numerator is the number of ways that the event can occur. I think there's 2 C's in occur. Divided by the number of outcomes. For example, and we'll do some examples of this in the next video. If I want to know the probability of rolling a die and getting a 5, well, a 5 can occur one way, and there are 6 different outcomes. So that's 1 out of 6. Now, this name is called just the classical method, classical probability method. And hopefully you see the difference between using the classical probability method and the relative frequency approximation method. The third main type of probability is just what our textbook calls a subjective probability. And I just like to call it kind of the seat of the pants, or just a wild guess probability. For example, what's the probability that somebody in Licking County will be electrocuted in the next month? Is that something that we can calculate exactly? Does that belong to the classical probability method? Well, no, we can't calculate that. Is it something we should experiment with? I don't think so. We really can't use the relative frequency approximation. For a subjective probability, usually you just have to base your probability, take a wild guess, and just base it on past history. And hopefully we have some past history recorded about the event. So these are the three main types. Now there's one more topic I'd like to discuss while we're right here, and that's the idea of a complement. There are two types of complements. One complement is the complement of an event. Given an event A, the complement of A is simply all the other possible outcomes besides A. So if I say that event A is equal to, while we're rolling a die, is rolling a 5, if that's event A, then the complement of A, and the complement of A is notated as A bar, just put a straight line over the A, then the complement of A is simply all other possibilities, which is rolling a 1, 2, 3, 4, or 6. It's every other possibility besides event A. Now, that's one kind of complement. Another kind of complement is the complement of a probability. The probability of rolling a 5, the probability of event A in this case, is 1 out of 6. We've said that. The complement of this probability is simply the number that it takes to add to this one to get 100%, or the number 1. Well, the complement then of 1/6 is 5/6. So we can say the probability of the complement of A is 5/6. And therefore 5/6 is also the complement of 1/6. There are two different kinds of complements, the complement of an event and the complement of a probability. They must always add up together to 1. So we can say one more thing here. The probability of an event plus the probability of that event's complement has to be 1. And for you algebra students, if I want to solve this little formula, this equation, for the probability of event A, I would have to subtract this probability of the complement from both sides. So I would end up with the equation that we can find the probability of an event A by simply finding the probability of its complement and subtracting that from 1. Sometimes, and we'll do this in later videos, sometimes you'll find that it's easier to find the probability of an event by first finding the probability of its complement and just subtract it from 1. Okay, so this ends our discussion on different types of probability and the two ideas of what a complement is.